Hi everyone, this is Amir Magub, PhD student civil engineering at Catholic University of America in Washington DC. Today I will talk about how to calculate land cover of stream watershed. First we need to go to USGS website, free access, and we need to access the land cover data for for the states. So this is the states right here. So you need to choose the state of your stream. So I will divide the calculation in two parts. Uh, the first part I will calculate land cover in Washington DC, and in the second video I will talk about the calculation in Maryland. So first I will take all the area in Maryland out, so I guess I will stay only with Washington DC area watershed, which start from here. So this is my watershed area in Washington DC. So first I add my raster file here from my download data. Uh, so this include all DC land cover data. So what I need to do first, I want to change this raster file to vector so I can work on it. So I will go to my toolbox. I will click this icon raster to vector convert. Okay, so this is already here my raster file right here, gap DC, and then feature type is area, and I might choose the first option, say smooth corner from the area feature right here, and then I will run the processing. Okay, it's complete. So as you see, the new layer come up here. So vectorize, so it's right here, the green color. So so what I want to do first, I will change the style of my vectorize layer. So I will go to properties, okay, and then I will choose categorized, depend on the value right here, and then I will click on classify right here. Okay, this is a new number. This is classification classification number of each type of DC land cover, which is attached in other files. Comes with my download data is right here. So if you go and match, you can match the value number with the name of the class right here. For example, 68 is forest and woodland. Okay. So I will click OK, and then as you see, my this is my this is the color is my land cover classification. Okay, the second step, I need to cut my land cover data to only to the boundary of my watershed. So my watershed is right here. So as I told in the previous video about how to merge many layers to be only as one layer, so you can use it in land cover data. So now I'll take my watershed out right here, and as you see, I already merged them on one layer right here. Let me get this out. So yes, this is my merge DC watershed, and this is my vectorized layer. So the second step, I will cut my data to the boundary of my watershed. So I will go to the save as right here, Okay, and then let's give a name, so we can say DC cut zone. Okay, make sure projection is match, and then I will go to extend right here, extend current layer, and I need to calculate the land cover in the boundary of my watershed area. So I will click here, and then I have to choose my merge layers right here, which is merge DC poly. Okay, and everything else stayed the same, and I will run the processing. Okay, and as you see, there is a new layer come up right here, so I will take this out. Okay, so this is only the land cover in the boundary of my watershed. Okay, um, let me change style, or maybe we can we don't need to do this. Let me just copy the style here, style, copy, and then I will paste right here, and then style and paste. Okay, so it's going to be the same style, and this is our DC land cover in the boundary of our watershed. Okay. Okay, so as you see here in the first column under value, there is my classification, my land cover classification in DC, start from series 8. Okay, so I will do some edit to my attribute table. Okay, I will go and add a new field. I can call it category. Okay, because I would like to categorize my DC land cover classification. As you see here, there is many repeating number in this first column right here, so I want to categorize similar number under one category. Okay, so I will go to the column right here and then click category, and then I will do the equation under case function. But before we do the equation, let me open this. Let me open the field on value, and I will go to value, and I want to see my classification. I see, as you see here, start from 38 going all the way down to 584. So I may put them under 6 categories. Okay, so let's go ahead and use a case function. So case when value is larger or equal 38 and value is less than 100, then category number 1. Okay, let me copy this. Let me copy it, and I want to copy it on this 6 times because we need 6 category. Okay, more I believe this. Okay, so let's go to the first line, less than 100, then number 1. Okay, and second line you can put here 100 and less than 200, then category number 2, and here 200 and less than 300, then category number 3, and here is 300, and less 400, then category number 4, and here is 400, and less 500, then category number 6. Okay, and the last one is larger or equal 500, and less 600 is in category. Sorry, here is category number 5. Sorry, I made a mistake. And the last one is category number 6. And less n case function with n. Okay, and you see there is our preview this example here 6. So I will click OK, and then update all, and you see under my category column my category, I categorize my classification to one number. Okay, so to unique number, like. Okay, and second, let me save the change. Okay, second. Okay, now I will go go and make the intersection between my DC cut zone layer and my DC mirror layer right here. So I will go to vector and view processing tools, and then I'll choose intersection. Okay, my input layer is DC cut zone, and my layer should be DC mirrored zone, which is right here. Okay, then I will run the processing. Okay, now I'm facing error because my geometry is invalid. Okay, so what I want to do, I will go and buffer both of my layer right here. So first I will go to vector, view processing tools, and I choose first choice buffer, and then I will change the distance. I will make my geometry like very smaller, so to minus 0.001. Okay, everything else stay the same, and I will save it. Actually, let me save it. We save the file, and we can call it DC. Okay, cut zone buffer. Okay, DC cut buffer. Then run. Okay, I will do the same for mirrored DC polygons right here. I will go to vector, and then I will click buffer, change the distance again from minus 0.001. Okay, and let me save it. Actually, I forgot to save it. We can save it as let me save it as, you can call it DC we can call it DC mirrored buffer. Okay. Save. Okay, and let me change the style. Okay, I'll comment style here. The base style. Okay. And okay. Now we're gonna go and run the intersection again. Okay, so I'll go to vector, view processing tool, run intersection, and okay, my input should be DC cut zone buffer right here, and overlay should be DC buffer right here. Okay, then I'll run the processing. Okay. Okay, now as you see the intersection new layer come up right here. So this is the intersection of my land cover classification only under my watershed area in Washington DC. Okay, I will open my attribute table. Okay, as you see, this is my classification number right here. Okay, my area and my area in square, my area label and my area in square meter right here. So what I'm gonna do, I will do some editing to my attribute table. I will add a new column. I can call it um, classes area. Okay. Okay. Because I need to calculate like how much area of my classes in each area of my watershed. Okay, so I will go here to the here choose classes area, and then I will do $sign area and click update all. Okay, now there is this is like how much of each of my classes in my watershed, in each of my watershed area. Okay, now in the last step, I will add a new field. You can call it percentage. Okay, it should be in decimal number. Okay, I can the links to this one. Okay, so now I need to calculate the percentage of each of land cover classification in my watershed. Okay, so I will go to percentage right here. Okay, and then let me do the equation. Okay, so the percentage is going to be equal classes area divided by my area, okay, times 100. Okay, okay. Update all, and as you see, this is a percentage of each class in my watershed in Washington DC. So I can do dissolve of my attribute table depending on the percentage. So let me save the change first here. Okay, and then I will do dissolve. Okay. Depend on my percentage. I just calculate. Okay. then run the processing, and you see it's dissolved right here. Let me open my attribute table, and you see yes, now we have a total of 40 feature right here. So they ignore all the zeros, and this is the percentage of land cover classes in my watershed in Washington DC. Okay, let me last step, let me classify intersection. Okay, and value right here. Okay, good. Let me rename my resolve. I can call it DC DC percentage. I can call it DC land cover percentage. Okay. Okay. Okay, that's it for today. Thank you for watching. I will see you in the next video.